All right, so as we continue with our introduction to R, we're going to start talking about the R console today. I think we looked at this last time, but this is going to be a little review. The R console is where the computations are performed. When I open my R session, this will automatically be open. I did fix this for some of you because depending on how your installation goes, sometimes it's not automatically opened along with the main R programming window, but you should all be able to get to this R console, and we're going to take a look at it now. So any expression that you put into the console, it will be automatically evaluated when you push enter. This is automatically done within the console window. You can do everything from running functions, building statistical models, to creating a graph. It's not the best way to have a long sequence of programming statements because it's not saved. This is just a nice interactive way to use the R system though, and you can always get back to your last expression using the up arrow on your keyboard. To get your value of the last evaluated expression, you just type last value. That's really useful when you're doing long computations on the console, which I don't recommend doing in general, but sometimes you do. You can always press escape if you stick yourself in a function that keeps spinning and you realize you do not want to run it in the console. Here are some of the functions that we can use. We'll practice evaluating these in the console here. Notice we have all the binary operators, the math functions, the trigonometric functions. We can round numbers, and then we can also use word-based expressions for mathematical quantities. So, for example, let's take a look at this modulus function here. Here I'm in the console window. I've simply typed that 5 modulus 4. I get back 1. Notice I could also, I just push the up arrow. If I push down there, up arrow, I get back the last expression. Then I could modify that slightly. I get the remainder function. I could also push up again, get rid of this, and I get 1.25, just the regular divider function, binary operator. So easy enough to use. Let's take a look at some of the other kinds of expressions. We can take logarithms, cosines, arc cosine, sines. We can get the ceiling of numbers, so that rounds it up. The floor rounds it down. Regular round, we'll just use regular rounding rules. If we try to evaluate an expression such as 0 divided by 0, we get back NaN. And if we evaluate something like 1 divided by infinity, we get back 0. So what we usually do in a SAS programming environment is we're going to create objects. There are really, essentially at core, 2 different kinds of structures in R. It's pretty simple. We have functions, and that's things that operate on objects and create maybe, perhaps, new objects. And then there are objects. So we can use an assignment operator to create an object. We can use it 2 different ways. We can use this left-going arrow to take, say, object is a number, like number 2, and then we'd assign X to be the number 2. We could also just use the equal sign. Notice that we can use the pointer argument this way as well. This, and this are all equivalent in R. The other way we can use programming statements in R is we can call functions. So here we have a function name such as GLM, and we want to use a list of arguments that are separated by commas to evaluate. Each function is going to have some default values, and we'll go more into that later in the course. The list of arguments could list every single argument or just a subset of them, and if you do not mention them, it defaults to those default values. We need to specify a particular argument, then you need to use that argument's name. So if you have model equals, then it'll specify the model being used is that value. Sometimes the functions will get confused if you don't use the argument name. We always use an equal sign when specifying those values within the arguments as well. One thing to remember here as we start going in R is that R is case sensitive, so capital GLM is different than lowercase GLM, and that applies to functions, that applies to objects or variables or assignment statements. Anything that we do in R, it is case sensitive. Okay, so let's do some tests, and as we go through these, I want you to open up your R console and test these out as we go. Okay, so we're going to use an assignment statement. So remember, we talked about objects and using assignment statements to declare an object. We're going to do that here, and then we're going to call a function. So we're using the two basic structures of R right away. So here we're going to create an object, and that object's going to be called X, and it's going to contain a column vector, which is components 0, 5, 7, 9, 1, 2, and 8. Here we've declared that object. Then if we just type X, that object, it'll show us the contents. You could also do print X to see the contents of X. You don't need to use print X except explicitly at times. Then we can compute the mean of this vector. So this value 4.57 approximately is just the mean of these 7 numbers here. Notice here it is a capital X. Why is that an error? Test it out and think. It's saying that object capital X is not found. Well, we have X declared, but remember R is case sensitive. So now suppose we want to do something like sort a vector. So here we declare a new object Y, and it's a vector, a numerical column vector, and then we're going to sort Y. We could sort it increasing or we could sort it decreasing. So notice here with the mean and here with the sort uses, we've used a function that operates on an object. Okay, first the object being X, then the object being Y. Okay, so the script editor is where we can save programs that we write in R. I always recommend you using the script editor for any work that you do in class, even if it's quite short. To open a new script window, you just simply click File and then New Script. Okay, so we can do this. Within the R window, you just go File, New Script, and now I have a script window. Let me show you a few little tips here. This is awkward. You can move this around as much as you want, but why have it so awkwardly placed? So you can tile horizontally your windows. So now my script window's on top, my console window's on bottom. I could also tile vertically. I go with one or the other. Sometimes I have very long lines of code and I do horizontal for that. Sometimes I want to be able to see a long range of code, and so then I'll vertically tile. You can arrange them any way you want. You can also use cascading or whatever. Okay, so within this scripting window, we can write our programming statements, and let's say I begin a programming statement X equals C. Let's just do a vector 0 up to 4. So I'm going to do this, just complete some computations like we've seen before. I can go through here and run each line. Notice there's a keystroke command here of Control R for running each line or selection, and that will run each line as I go through. So here I'm going to just do Control R, and notice over here on the console, whatever I'm running gets computed. Or I could Control A, Control R, and it all gets run at once. Or I can go up here and just do Run All. Either way. I can then save my work wherever I want. I'm not going to save it today, but you just go to your directory. I like to save first script. I like to create the extension R. On some systems, it will save it as a text file by default, depending on your system settings. So it's just a good idea to always save it as an R file intentionally. I'm going to cancel that for now. Or maybe put it on my desktop just to show you it works. So now up there it's saved on my desktop, the first script file. Then if I were to accidentally close that and I go, oh no, I wanted to have that open, I can go straight back to my desktop. And there it is. So I open it, vertically tile again, and I'm back where I started. So a nice way to keep your script. It will not save what's in the console file, but just your code as it is scripted. All right, so this goes back over the Control-R, Control-A, Control-R. I'll let you read this all on your own. You don't need semicolons at the end of each line, but if you have multiple programming statements on any given line of your code, you will need to separate them using semicolons. I can show you that later. You can use comment out code using a number sign. There is no block commenting in R, but you can kind of create, quote, blocks of comment. You'll see that in some of the code I give you during the semester. Comments, again, are really emphasized as being useful. I will grade it on your homeworks. It helps you remember what you've done and why you did it. And nothing is more frustrating than opening a block of code and thinking, what was I thinking and why did I write it this way? Because I cannot remember any longer. All right, so we'll pick up there next time and finish up our introduction to R.